Welcome to The Explainer. Today, we're tackling a really critical challenge in corporate sustainability. How do we evaluate environmental data fairly without being totally misled by raw numbers? We're going to dive deep into the SASB standards for solar technology to see exactly how they solve this massive analytical blind spot.
Let's start with Section 1, the trap of absolute numbers. Let's look at a real-world scenario.
When investors, regulators, or even just consumers look at corporate sustainability, there's this really natural tendency to just fixate on absolute numbers. If a company reports a massive figure for total energy consumed, our immediate instinct is to flag them, right? To say, wow, that's a heavy polluter. But relying solely on absolute metrics is a really dangerous trap because it completely ignores the fundamental reality of business operations, which is scale. Imagine we're looking at two vastly different solar manufacturers. One is this massive global enterprise churning out millions of solar panels that power entire cities. And the other? Well, it's a boutique regional manufacturer producing specialized panels for a very small market. If we put their sustainability reports side by side, how can we possibly judge their environmental impact fairly? If we don't level the playing field, our entire analysis is literally flawed from the start.
Let's dive into this paradox a bit more. Consider this hypothetical comparison. We have Company A, and they have massive, eye-watering energy use. Then, right next to them is Company B, with just a fraction of that energy use. If you're just skimming the raw data, you might immediately conclude that Company A is the worst environmental actor. You might divest from them or, write a scathing report. But does using 10 times more energy automatically make them the worst polluter? Or are we missing the single most important piece of the puzzle here?
To resolve this exact problem, we turn to Section 2, SASB Activity Metrics.
We're specifically looking at the standard for the renewable resources and alternative energy sector. To prevent analysts from falling into that trap of absolute numbers we just talked about, SASB introduced something incredibly powerful. Table 2 from the SASB standard establishes the exact activity metrics designed to solve our comparison problem. Now notice that these metrics don't measure sustainability performance directly. They don't measure carbon or water. Instead, they measure the physical scale of the business. By requiring companies to disclose these specific operational figures right alongside their sustainability data, SASB actually gives us the master key to unlock the real story.
Let's look at exactly how the standard defines the purpose of these tools. Right on page 3 of the source text, it explicitly states that activity metrics are intended to, and I quote, quantify the scale of specific activities or operations by an entity and are intended for use in conjunction with the metrics to normalize data and facilitate comparison. So the absolute crucial point here is that context is required to make data actionable. You simply cannot evaluate a company's environmental footprint without knowing how big its footprint on the market actually is. It's like trying to judge a race without knowing the distance.
Let's move on to Section 3, the 3 key indicators. So, what specific tools does SASB actually provide for the solar industry?
How do we actually measure the scale of a solar company? Well, the standard outlines 3 distinct standardized activity metrics that every company in this sector is asked to report. First, the total capacity of photovoltaic, or PV, solar modules produced. Second, the total capacity of completed solar energy systems. And third, the total project development assets. By breaking the business down into these 3 core areas, analysts can accurately gauge the true physical scale of a company's operations. Whether they're just manufacturing the raw panels, or if they're out there actually building and developing full-scale solar farms, we get the whole picture.
And this brilliantly illustrates a vital shift in how we analyze sustainability. Notice the unit of measure for those first 2 metrics. It's not revenue, it's not dollars or euros, it's megawatts. We are shifting the focus entirely from financial output to physical energy capacity. This is absolutely critical because environmental impacts, like, say, water use in manufacturing or hazardous waste generation, well, they scale with physical production, not with the fluctuating market price of a solar panel.
Of course, for these metrics to actually enable fair comparisons, we need to look at Section 4, defining the exact boundaries.
Because we can't just have companies guessing or making up their own definitions of what a completed system is, right? We have to establish rigorous technical boundaries based on the specific footnotes provided in the SASB standards. According to footnote 4 of the standard, a completed solar energy system is strictly defined as any system that converts sunlight into electrical energy, and this covers both PV systems and solar thermal electric systems. Plus, what constitutes completed must be defined by the entity in a way that is perfectly consistent with its existing public financial disclosures. Basically, you can't claim a system is completed for your sustainability report if you haven't claimed it to your financial investors. Makes perfect sense, right?
Now the third metric is a bit different.
It's measured in presentation currency, like dollars, rather than megawatts. Footnote 5 clarifies that project development assets must include, at a minimum, capitalized costs for systems that are under development or fully developed systems that are owned by the entity and held for sale prior to a definitive sales agreement. This is super important because it captures the massive physical scale and footprint of a company's future pipeline, a pipeline which requires significant land use and community engagement today, even before a single megawatt is actually generated.
Let's move to the climax of our scenario here in Section 5, Proof by Calculation.
Okay, we're going to apply these strict definitions to our initial comparison and finally normalize the data. Walk through this math with me because it reveals a pretty incredible plot twist. In our comparison, Company A consumes 1 million gigajoules of energy. Company B, only 100,000. But look at the capacity produced, that activity metric we just learned about. Company A produced 5,000 megawatts of solar capacity. Company B, only 200. So when we do the math and divide the total energy consumed by the capacity produced, look at the result. Company A only uses 200 gigajoules per megawatt. Company B uses 500. So Company A, despite having a massive absolute footprint, is actually 2.5 times more energy efficient than Company B.
The core takeaway from this analysis is that normalized data reveals the truth hidden by absolute numbers. By utilizing activity metrics to calculate intensity, in this case energy consumed per megawatt produced, we provide the vital context needed to evaluate corporate efficiency equitably. Without taking this step, we literally would have heavily penalized the far more efficient manufacturer simply for being successful and operating at a much larger scale.
It really shifts your perspective, doesn't it? I mean, if a massive solar manufacturer can look like a terrible polluter on paper until we normalize the data against their megawatt production, how widespread is this issue? What other industries, from agriculture to tech to heavy manufacturing, are hiding their deep-rooted operational inefficiencies behind comfortably small absolute numbers? The next time you're handed a sustainability report, before you judge the raw data, you really have to ask yourself, where are the activity metrics?